Hey, bro.
Yeah, it was
Awesome. I know this. I know.
I don't have one problem, I got a problem. There's nothing on the.
Do you think Dr. Snowden is gonna give us a title for the class? Yes, so. Here's going to my.
Oh, he is.
Do you think Dr. Snowden is gonna give us a title?
Yeah. Oh,
Last year, or two of
no, like, I about.
Like, you're
We actually read it.
Oh, not.
Oh, sorry, I didn't.
Yeah, biology had like a DOC. That's what you go for.
We didn't ask.
Like I can't, so last year, like, I can't even.
Okay, guys, you guys turn to page 9. Okay, bottom of the page. If you need scratch sheet, feel free to grab some. When you're verifying identities, you can either start from the left and move to the right, or you can start on the right, move to the left. I think this one, I think it's easier to go from something that's more unfamiliar to something that's more familiar. So I'm actually going to start on the tangent side and work my way to the sine side. So I rewrote it, the tangent on the left and then sine on the right, but you can just go ahead and we'll look at the left side. We're trying to make our way to the right side. What is one obvious step you think we can take to begin with? Yeah, let's get all the tangents to convert to be sine and cosine. But we can immediately see there's going to be some problem. There's some issues we got to work through, right? As soon as we get this to sine and cosine, what do you think our next step will have to be? And by simplifying,
Getting the same thing down.
yeah, common denominator, right? We're probably going to have some multiple, yeah, so we'll try to get it down to a common denominator, and then we'll see what we can do from there, okay? All right, so. Now, both my numerator and denominator, we're going to have to go through common denominators, right? So let's focus on one thing at a time. So I'm just going to focus on this top portion here. What do you think the common denominator will be if I'm just looking at this fraction here? Yeah, cosine A, cosine B, right? If you see two things that are different, you just need to include both things. Okay, so we don't have to be clever with the way that we create common denominators. We're just, if there's two things, then we'll include both. Okay, so now we got to go through and balance each of the fractions here. So from old to new, we see some difference. What do we need to get? What do we need to get from this old denominator to this new denominator? We need cosine B, right? So whatever we need, that's what we're going to do to the top. All right, between this old denominator and this new denominator, what do I need to add? I need a what? Or what's missing here? Cosine A, right? So whatever's missing is what I need to do to the top. So technically, we can get this all under one fraction. I mean, we're not going to get it all cleaned up, but at least we can merge it into one fraction now. I mean, it's still messy, but at least it's one fraction. All right, are we okay with that top numerator portion working all the way down to just single fraction, as messy as it is? Okay, so now moving on to the denominator here, this 1 minus sine A sine B over cosine A cosine B. Again, I like to put this under one fraction or merge these together. What do you think the common denominator here is? Cosine A cosine B, right? So if my denominator is 1, it's just going to take on whatever the other denominator is. All right, I need to balance my first fraction here. What's my numerator going to be? Cosine A cosine B, right? Any adjustment needed here? No, just going to be the same. Oh, I took it from the original problem here. I converted the tan A tan B to be sine A over cosine A, sine B over cosine B. And once I got that fraction to show up, I realized I got to go through common denominators. The nice thing here is, as messy as it looks, at least we can merge these two fractions into one fraction. Now that I have a fraction divided by a fraction, what can I do to multiply the denominator by the reciprocal? So this divided by this, the same thing as this multiplied by the flipped denominator. All right, anything go away nicely for us? And if I put the resulting terms under one fraction, is that going to match my answer? Yes. Let's go to page 10. And let's do, yeah, questions. Oh, I got rid of the 1, right? So we know 1 is 1/1, right? 1/1. So what is the common denominator between the 1 and the cosine A, cosine B? So once I establish that common denominator, I ask myself, what will it take for me to get from 1 to here? I need this whole thing to get to here, so I need to multiply the top by the same thing as well. Okay, let's look at. Yeah, a lot of this just common denominator is where the messiness comes in. Yeah, let's try number 2, page 10 here. Yes.
How do you know, like, which side is the better one?
Yeah, I think on the quiz, I'm just always gonna make it where just always start on the left side, so you don't have to choose. Yeah. But typically, the rule of thumb is you go from the more complex, unfamiliar side to the easier, simpler side. But I know that's not 100% true, but usually that's the case. All right. All right. Eventually, we're gonna have to convert everything to in terms of sine and cosine. Maybe we don't want to do that just yet. Do you see something that maybe can allow us to clean up that left side a little bit? Yes, eventually, good. Anything in the numerator that's a quick fix, that's a quick, yeah.
Can we like now the secant is squaring, like it's divided by secant again, so it's basically.
You get rid of the denominator, just keep it secant. And secant minus integral squared.
Yeah, you know what, there could be,
Let's make it.
yeah, I think, okay, so I think there are multiple ways to get to the answer. I think that could work, splitting up into individual fractions or getting that secant squared to show up. But the first thing that pops up is I see that secant squared minus tangent squared, and I'm thinking, okay, maybe that's a quick fix I can do here. What's secant squared minus tangent squared? 1, right? So I can just quickly get that messiness to go away. I know it doesn't feel like we're any closer to the answer, but we're dealing with a simpler problem. So right. What about now? Let's see, say it again. What did you say? Hmm. Yeah, I think that could work. Yes. Yeah, so yeah, that works. So yeah, convert everything in terms of sine and cosine. And then common denominator, and then flip that secant, flip that cosine up. My other I think the way I was thinking was splitting up into individual fractions and then dealing it from that way. I think that may be a little bit faster, but I think your way works too. So I'll go through both ways. Okay, so one way is Let's just convert everything from the sine and cosine. What's my common denominator for my top portion? Is cosine. Balance this fraction here. Cosine over cosine is 1.
One plus tan theta.
The reason why is because we played with this secant squared minus tangent squared. I'm able to use an identity to get that to go away because I know that 1 plus tangent squared is secant squared. So secant squared minus tangent squared is just equal to 1. So this whole thing just goes away, it just becomes 1. So this piece. All right, so now that I have a common denominator, I can merge the two fractions together. Yeah, this may feel like a more familiar path since we've been doing problems this way. Multiply it by the reciprocal. Once I get that cosine to flip to the top, I can see cosine goes away nicely for us, which is left with cosine plus sine. Now, the other option I was thinking of was going ahead and splitting these up into individual fractions. So I just want to show that way as a possibility as well. If I split that fraction up, I can make it 1 over secant theta plus tangent over secant. The reason that I did that is because, well, I knew that I was going to end up with 2 terms. So if I just go ahead and split that up early and then just take care of each individual one. So 1 over, well, we know that 1 over secant is just cosine. So that's a quick fix. This second one, though, is sine theta over cosine theta all over 1 over cosine theta. And if I multiply by the reciprocal, it's the same thing as times cosine over 1, and then the cosines goes away, and I'm just left with cosine. I'm sorry, with sine. But this way, even though it feels a little bit longer, I know it's more familiar to us because we've been doing it this way. So this is so, that goes to show, sometimes there's multiple ways to get to the same answer. But I want to show you, different methods so that you can kind of have that in your back pocket. When one doesn't work, you can try something else. All right, let's try number 4. And then we'll go to page 11 because I think 5 and 6, it feels familiar because we just find common denominator in terms of sine and cosine. But 4 feels a little different. Let's try number 4. And I will say this, that, if you're seeing that I'm doing something completely different than what you're doing, but you're still able to get to the conclusion on the right side, that's fine. You'll still earn full credit, even if you're not working through the same way that I am, as long as every step is confirmed and verified and you're not making up a step, right? So don't think that, but if you want to check with me afterwards and, hey, ask me if the way that you did is right. So it's just to show that, there's multiple ways of getting to the verifying. So how would you start this one? Yeah, I'll just expand everything out. That's what I did. I mean, yeah, eventually we'll convert everything in terms of sine and cosine, just so we can see some matching parts, but I want to just get that parentheses to go away and we can kind of discover what we have left. Okay, what's next? Start getting what to, I don't see any like terms here. Okay, we'll just do next. Sine, cosine, yeah, that's what I was thinking. So I have 4 fractions here. Do you think we can find a way to merge all 4 fractions together? If we find a what? Common denominator. Is there a quick common denominator that we can use for all 4?
Cosine.
Cosine sine, right? Cosine sine is large enough so that every one of these can go into, right? So okay, so let's look at each fraction to see if there's any adjustments that need to be applied. Any changes from this denominator to the new one? No, no changes. So just bring down your numerator. Any changes from the old one to the new one? By sign, right? I need the sign, so that's what I need. That's why I'm going to have to adjust in the top as well. Any changes? No, so just bring down sign. Any adjustment needed? Cosine. Oh wait, sign, right? Okay, what's nice about this, well, these 4 fractions here? Anything that can cancel can go away quickly for us? The middle ones, right? That's nice. And the rest, let's just merge together into one fraction and see where that takes us. Because now that we have common denominator, we can put all into one fraction. All right, anything stand out to you here? Identity, 1 minus sine squared is cosine squared. What's next?
Sine theta and cosine theta.
Yeah, let's do that, sure, yeah. Let's just see the different parts. Get everything all lined up. Okay, how's that? Yeah. So I'm left with cosine over sine. Cosine over sine is the same thing as cotangent. That's what we're trying to reach towards, right? Okay, page 11.
What's the main format of the quiz?
It's just gonna be like maybe 5 or 6 problems just verifying, where you just, yeah. It's like this.
Will we have like an identity like on the board?
Um. Let me get back to you with that. I feel like I'm okay giving you like the co-function and the even and odd, but I do want you guys to know these three. So again, you know the first one, right? That's easy to memorize. So really, that's the only one you need to memorize, because these other two you can build just by dividing everything by either sine squared or cosine squared, right? Divide everything by sine squared, I can get to this last one. Divide everything by cosine squared, I can get to the second. So I think that's really good to know. It's helpful for next year as well, just to be able to know these three identities. So you memorize one and you derive the other two. Okay, page 11. Okay, we're going to start on the left and move to the right. So I think what we can do is let's get these exponents to show us something that's more familiar, right? And what I mean by more familiar is something that's in terms of square, right? Because we can get in terms of square, then we can start converting it in terms of using our identities. So first thing I want to do is kind of separate my sign. If I can take out one sign, I can at least get it down to an even power. And then sine to the fourth is really, yeah, it's 2 sine squared, right? And then, well, I can get it into something that feels familiar, but I just know that it's going to be squared. And we want to have a collection of sine and cosine squared because we know those are easy to convert to something else. So we're able to break that fifth power down into something that feels more familiar. Now we look at the right side and we see, okay, we already have sine, so that's nice. We already have that piece of the puzzle. And everything else is in terms of what? Cosine. So this one is good to go. We just want to play with what? Play with that sine squared, right? Because I can get that sine squared to be in terms of what? Right, in terms of cosine, and that should help me move towards this piece that I'm trying to get to. So I'm just going to carry everything down, but I know I can adjust that sine squared to be 1 minus cosine squared. Am I any closer to the right side? if I can find a way to merge these together, thank you. Right now.
Yep.
So I'm going to FOIL this out and then distribute that cosine squared through. So I'm going to take care of this piece first. And then once I have that adjusted, then I can distribute the cosine squared through, and hopefully that will end up looking like where I want to go. That's the 1380 is the suite. She can just ask who's trying to find it. Okay. 1 minus cosine x is 2 cosine x. Oh, I'm sorry. It's cosine squared here already. So I need to multiply the 1 minus cosine squared through, which means that I get 1 minus cosine squared there's going to be 2 cosine squared x, and then cosine squared times cosine squared is cosine to the what? Fourth. Yeah, sorry about that. Right. If I distribute the cosine squared through, and when you multiply bases, you're going to add exponents. So you don't do 4 times 2, you do 4 plus 2.
It's being because you take out the.
Are you talking about getting from here to here?
Yeah.
Okay, so let me write out all the steps here. So if I distribute the 1 through, I get 1 minus cosine squared x, and distribute the cosine squared x, so minus cosine squared x plus cosine to the 4th x. And if I merge these two together, cosine squared, negative 1 cosine squared minus cosine squared is going to be minus 2 cosine squared. And then once I FOIL this out, I can distribute the cosine squared through, and that should leave me with my goal. Does that match? Yeah.
Wait, how did you get the 2 in front of it?
Oh, how to get here? Right, so when I FOIL, it should look like this. And then you see there's 2 like terms here, right? So my negative 1 cosine squared x minus cosine squared x will be minus 2 cosine squared x. Question? All right, number 2. Page 11. So the strategy I have on the left side is let's just get as many sine squared and cosine squared to show up, because we know that we can play with our identities once we get the square to show up. So as soon as I take each step, I'm looking to see what my goal is and what I can do to get closer to my goal. Okay, what do you think we can do here from here? Or what can we keep and not have to worry about? The cosine x, right? So we can kind of remove that from our option, right? Because we know that cosine x is going to have to be in our final, so we know that we'll do anything with that. So what do we want the rest of the expression to be in terms of sine? Which means that what's the only thing that we need to change?
1 minus sine.
Yeah, that cosine squared, right? I think that's the only thing we need to change, right? Because everything else should line up nicely for us, right? The cosine is good to go. This is already in terms of sine. We can distribute that through once we get that cosine squared taken care of. I'll go ahead and move this cosine x to the end. And then I'm going to put this back together. Sine x and sine squared x. I can make this turn back into sine cube x. I just got this in terms of sine squared just to kind of see what's available. But now I'm going to put it back because it looks like I didn't need to clean it up. Now what can I do? Am I any closer to my goal?
You distribute.
Yeah, if I distribute the sine through, I should be able to get that to match up nicely here. So anything times 1 is itself. Anything where if I'm multiplying sines, I add exponents. So that should give me that 5. Okay, number 3. Okay, let's do. No, actually, you know what? Let's do number 4. I think 4 will be good for us. Because we've done basic factoring, but we haven't done anything that requires a trinomial factoring. Okay, so the sine squared can be easily converted to be in terms of cosine squared, which is nice. But the numerator, it's already in terms of cosine, which is fine, but looks like there's something that we can do with factoring. So I want you to see this process here. What if I rearrange this and made it look like this? And I'm just going to go ahead and take care of my denominator. Sine squared is 1 minus cosine squared. I got everything in terms of cosine. That's good to go. Now, I want you to look at this numerator here. What if I were to factor a -1 out? Which means I got to change the sign of everything inside. Okay. Are we good from here to here to here? Now, do you see something that we can do here? Does this feel recognizable in terms of factoring? Okay, let me ask you this. If I ask you to factor 4x squared plus 3x minus 1, Would you remember how to do this? Been a while, right? Factoring? Okay. So let's talk about this. Okay. So if you're factoring with a leading coefficient that's other than 1, I like to go through this little star method here. So let's do factoring in terms of x, just it feels more familiar, and we can bring in the cosine. Okay. So let's just pretend like we're doing a simpler version of the problem here. So factoring. So factoring, what we do is we have our a, our b, and our c value. Okay. Your a times c goes here, your b goes here, and your a goes in this bottom slot. So, okay, so what's a times c? -4. And then my b is 3. Go ahead and fill in your a values here. So now the puzzle you're trying to work through is this. What two numbers multiplies to be -4, and those same two numbers adds up to be 3? 4, -1. 4, -1. Let's double check that. 4 times -1 is -4. That checks off. 4 plus -1 is 3. That checks off. So now we got to involve the denominator here. If it can reduce, it reduces. But if it doesn't reduce, we got to do something with it. Does 4 over 4 reduce? 1. So I'm going to put that. Yeah, star method. The star method. X minus. If this doesn't reduce, so I do x minus 1/4. If my factor, if I have any leftover fractions, I'm going to pull that denominator in front of the x. So now I factored everything in terms of x, but my variable is cosine. So I just have to put cosine in for the x, right? Because we factored a simpler version of the problem, but we did it in terms of x, so it just feels more familiar. But ultimately, our variable is cosine. Okay, so I'm just bring everything down here. The -1 is still part of my process. My denominator I can factor. Difference of squares. Well, minus cosine squared turns into what? Well, yes, but we want it in terms of cosine, so we do difference of squares, right? So a squared minus b squared is a minus b times a plus b. All right, what goes away nicely for us? Now let's look at the leftover here. Distribute the negative through. And have something that matches our answer. Okay, we'll do review tomorrow. I will have a help session tomorrow morning and 5th period. If anyone wants to come in, I'll send out a reminder. If you want to come in, we just want to do some additional practice. And then we'll do a review tomorrow and then quiz on Thursday. All right, phone me, get your phones.
That's great. Is there another way you can do factoring besides like this one? Is there another way you can do that?
There's guess and check.
Yeah, I just made her.
Sorry.
I just made her a table before.
Yeah.
Try to print.
Variation. So yeah, so you did.
Then you did it.
Big guess and check.
And you got it for 6.
All right, thank you.
Thank you.
I broke that sine to the 5th into sine x and sine to the 4x. And then sine to the 4x, I can break it down into the sine to the 4x. Same thing as sine squared x. So I made it into this. One way, maybe, factor using,
I'm not.
so you gotta think about what multiplies to be.
That's what I used to do.
So then you do it this way, then one multiplies to be negative less than 3. You have. Negative 4.
It means that it has.
Sorry, 4 and negative. So then you can do.
Because in the next one, extra balance. See, dichromate is.
Yeah, that's what. Because the negative side doesn't matter to me.
Yeah.
I think what, I think it'd be like the C value on like the city, you know.
I mean, you definitely do 4 and negative 1. So that,
Yeah. I'm saying like the very beginning.
yeah, I can do -1x plus 4x.